Throughout history, we've always known there are 6 planets. These are the planets anyone can see with the unaided eye. But 200 years ago came the discovery of Uranus. Less than a century later, Neptune, planet number 8, was found. And it's only 50 years since an immense search of the heavens revealed Pluto, the most distant planet we know of. But could there be more? Mathematicians have worked out the laws that govern the planetary movements. The solar system is a finely balanced mechanism. It's all terribly neat, provided you include the mystery factor, Planet X. Without the X factor, the theory collapses. At observatories all over the world, the search is on for a Planet X beyond the known bounds of the solar system. If astronomer Bob Harrington finds it, he'll be able to join the elite group of men who've actually discovered new worlds. Other astronomers are using a telescope in orbit round the Earth to give them a better chance of picking out the distant planet from the billions of specks in the sky. Today's planet hunters have a real battery of high-tech aids at their disposal. But the first man to discover a new world, back in 1781, had none of these artificial aids. In fact, by profession, he wasn't even an astronomer. He was a musician and a composer. So, Carol, how did a man like William Herschel come to discover the planet Uranus?
He quite simply started off with a book like this, called Optics, which told him everything about making telescopes and everything about what to look at in the sky. And he started off with his telescopes, with small ones, going bigger and bigger and bigger, to something of this size, a 7-foot telescope.
It's beautiful, isn't it? Lovely mahogany.
It's a fantastic telescope and beautiful to use as well. And Herschel himself set it up in his back garden at Bath. And he was a real amateur astronomer. And one particular night he saw something that he knew wasn't a star, had a different look about it, and he thought it's a planet, but that was too fantastic to be true. And so he thought it must be a comet, and he saw a few nights later that it had moved and was convinced it was a comet. But it was only when other astronomers said to him that in fact it's not a comet, it's a new planet, that he really believed it.
If you watch a distant planet over a period of time, it moves in a characteristic way. Because Earth too is moving, the planet appears to loop backwards in the sky before resuming its forward motion. And the speed is a dead giveaway. It tells you how far away the planet is. So how far out was William's new planet compared to the ones we already knew about?
It doubled the size of the solar system altogether. So there was a brand new solar system after just one night's observing.
So the 6 known planets of the solar system were joined by a new discovery, Uranus. It's nearly 2 billion miles away from us. Even so, Herschel worked out that Uranus was a giant planet 4 times bigger than the Earth. He also managed to discover it has 2 moons. And since then, astronomers have found 3 more. All these moons circle the planet at a very strange angle. And that shows that Uranus itself, seen here in this artist's impression, actually spins on its side. So if you were loony enough to want to go and take a holiday on Uranus, the hottest place to go wouldn't be the equator, but the poles. And that's pretty well all we knew about Uranus until 1977, and that's when Jim Elliott came along.
Well, what we wanted to do in 1977 was to measure the temperature of Uranus's atmosphere and measure how big Uranus was. 2 very fundamental things you'd like to know about any planet. And we had an unusual opportunity then in that Uranus was predicted to pass in front of a bright star.
It's a straightforward technique. Monitor the star until the planet hides it. Then pick it up again the other side. That way, you find out the depth of the planet's atmosphere and how big it is.
Now, the only problem with this was that due to the alignment of the star and Uranus, we had to do these measurements in the middle of the Indian Ocean.
For that, NASA had the answer, a flying observatory. Jim McClenaghan was the flight director on the night that Jim Elliott was to make his observations.
All of the hardware has to work just at the very moment of this observation. And so the tension, and that night, everybody involved in the mission was very tense, very nervous about the hardware, the tracking system, the computer system, the telescope pointing system.
Yeah, there she is. We're tracking. Bingo. Okay, left. Okay, can we store that position now? Okay, let's go to the sky. Okay, let's have a sky, guys. Let's start this one at 20:04, I think. Wait a minute, we gotta get dark slots. Channel 1. Okay. Channel 2. Have you lost your box? Channel 3.
Yeah, I lost my box.
Suddenly, the experimenter called out that I've lost my signal.
I got it.
A few seconds later, his signal was back online and everything looked normal again. So everybody was looking at the hardware, looking at all these controls and switches. And soon again, he cried out, my machine has stopped measuring anything. So we thought, well, we've blown it. And it happened several times. But for the most part, the signal that he was measuring looked typical of a occultation signal. And it was just these spurious glitches in the signal that were not understood. And our assumption at that point and that night was that there was some malfunction in some of this hardware of unknown cause.
But what it really turned out to be, we didn't find out till a few days later when we went back to the States to analyze our data. And this chart has our data, and I'll show you what we found.
It's a big one.
Okay, we can look more carefully at this chart of our data that we made during our flight. Here's the first dip that we saw. You notice the trace goes down, back up again, and up to the normal signal level. There's one. If you pull the chart out, you can see we have another one.
And also on that one there and there,
Yeah,
they're both channels.
That's our other channel. And we have a fourth and a fifth.
So they had 5 unexplained dips on one side of the planet.
Now, it's a very long way. We have to pull this chart in.
How long is it?
I think it's about 80 feet. I never really measured it exactly. Pulling and pulling.
Okay.
And now we come to what we saw on the other side of the planet, where we have 1, 2, 3, 4, 5 dips.
And there were 5 similar dips on the other side of the planet.
And the interesting part from all this is if we sort of reverse this and turn this over, we can match up each of the 5 dips on one side with a dip on the other side. We'll take these 2 here as an example, and you notice that this distance between this pair is the same as the distance between these 2.
So they had 2 symmetrical patterns of dips. There could be only one possible cause: a set of 5 rings. And in January 1986, the veteran Voyager space probe at last showed Uranus in close-up. It confirmed Jim's 5 rings and found another 5 too, all astonishingly thin. By tracking a small white cloud high in Uranus's atmosphere, scientists were at last able to find out the length of the planet's day, just 17 hours. Voyager discovered 10 small new moons, bringing the total to 15. And what really amazed astronomers were the landscapes on the moons we already knew. Oberon, the largest. Cratered Titania, its near twin. Umbriel, with its mysterious white oval. Ariel, grooved and wrinkled. And Miranda, smallest of the 5, whose twisted, broken surface defies description. Was it, as some scientists think, smashed to pieces, then reassembled in space? Even as the NASA scientists sift through the data from Uranus, Voyager is speeding on to the next planet out. Neptune, a world discovered only in the last century by a man without a telescope. The man was John Couch Adams, a student at Cambridge, and he used mathematics to find it. If a mystery world, Planet X, lurks somewhere out there, its gravity will give it away. A planet in a circular orbit normally travels at a constant speed. But if it passes near another planet, its speed is changed by the gravitational pull. By working out the speed of Uranus, Adams was able to predict the position of Neptune, which later led to its discovery. But to be honest, it wasn't quite as simple as that. Adams told his professor James Challis. Challis was cautious and passed Adams on to the Astronomer Royal, George Airy, who wasn't impressed. Meanwhile, in France, Urbain Le Verrier made the same prediction as Adams. Airy heard the news and told Challis to start a search, which was unsuccessful. At the same time, Le Verrier told the Berlin Observatory, where Johann Galler found Planet X straight away, just where Adams had predicted it. All of this astronomic farce could have been avoided if only Challis had listened to his student in the first place. Cambridge University is renowned for honouring academic distinction. Over to you. By the way, what are we celebrating?
We're a society of Cambridge undergraduates called the Challis Group. And once a year we have a punt expedition to celebrate Challis's total ineptitude at finding this planet Neptune.
Well, I'll drink to that. Have some more champagne. It's a long way from the lawns of Cambridge to the planet Neptune. About 3 billion miles to be precise. And I had to go to the University of Arizona at Tucson to find out more about it.
What kind of planet is Neptune then?
Neptune is a planet rather similar to Uranus. It's somewhat smaller, also somewhat more massive. Its atmosphere is mostly hydrogen, but we know that its interior cannot be mostly hydrogen. Instead, according to current thinking, the biggest constituent of the interior is probably water. And we think that it's probably warm enough so that the water is in the liquid state rather than in the solid state. So you might say that Neptune is an aptly named planet.
Neptune is so far away, we can hardly see what it looks like. This is an artist's impression of what we may see when Voyager gets there in 1989.
Bill, are there going to have to be any changes when Voyager 2 arrives at Neptune?
There may have to be changes because in the summer of 1984, our group found that there was debris at a distance of about 45,000 miles from the center of Neptune.
And so Voyager might plow straight into it?
That's a possibility.
What have you done? Have you rescued it?
We have reported this to the navigation group at Voyager, and they're studying how to change the trajectory.
The original flight path took Voyager straight through the debris that Bill Hubbard was talking about. It'll now probably pass Neptune on a slightly altered trajectory, skimming past the large moon Triton, and finally escaping into space. But even after the discovery of Neptune, things didn't quite balance up. The X factor still remained. The search for Planet X became an obsession for this man. Having studied Neptune's orbit, he was convinced that yet another planet lay beyond.
In the very early portion of this century, Percival Lowell became interested in the possibility of another planet beyond the orbit of Neptune. He based this on some irregularities in the motions of Uranus and Neptune, as if there was some other mass out there pulling on them. He set up searches as early as 1905, and they had several attempts without success. Percival Lowell was a very frustrated man and keenly disappointed that he could not find his Planet X. But he charged his staff, younger staff, to keep on looking. And, of course, in 1929, the new search was set up with a more powerful instrument, and I was invited to come out and run the instrument, and then later assigned to examining these plates under the blink microscope comparator. That's where you
Clyde Tombaugh is the only man alive to have discovered a new planet.
How did you get involved in all this anyway?
I was an amateur astronomer, and I had made drawings of Mars and Jupiter with my homemade 9-inch telescope and sent them to the Lowell Observatory, and they were impressed with their quality and invited me to come out on the staff.
As a young man, he used Lowell's predictions, coupled with his own stubborn persistence, to search the night sky. By day, he scanned the photographic negatives on a device called a blink comparator.
And how does this beastly work?
Well, we have two plates made on different nights, a few nights apart, of exactly the same region of the sky, so that you can freeze everything in there within an hour's time. And then you put them on here to compare one against the other, and you have the image of the stars, say, in the same place in the field of the eyepiece. And so when you have them well adjusted and well matched, you're hardly aware that you're looking at two plates in rapid succession. But let anything change brightness, like finding variable stars, or shift position, it stands out. But you still have to see, if you're going to the limit of the plates, you have to be conscious of seeing every star image to the very limit.
Can I take a peek?
Sure, yes. Now this little thing here is one field and then the other.
Oh. It's jumping from one to the other as it moves.
Now the shift on these plates, the Richter scale, is 1/8 of an inch in 6 nights.
That much.
And then I got out the third plate, which was 2 nights earlier, which was not as good a plate, to see if there's an image in the right place, and it was. So then I felt 100% sure. But when I saw these images, I said, that's it. I knew instantly, knowing the scale of my plates, that the object was way beyond the orbit of Neptune. I knew it instantly, and it was a terrific thrill.
Clyde's planet was called Pluto. It completes the solar system as we know it today, 9 planets and a star called the Sun. But even so, there was something nagging about Pluto. It wasn't nearly as bright as had been predicted.
It was about 5 times dimmer than we expected. And so there was some doubt about the mass. And so Dr. Lampin took long exposure photographs with a big reflector to see if he could find a moon, and which would tell us its mass, but he did not find any.
For 50 years, astronomers have been worrying about the mass of Pluto. If it's not big enough, then Pluto can't be Percival Lowell's Planet X. These 2 men at the US Naval Observatory in Arizona finally found the key that would unlock the mystery in the shape of Pluto's elusive moon.
Well, the temperature would be down at 20 degrees most of the night.
It must have been duvet jackets.
Did a lot of jumping.
Jim, jumping to keep warm apart. How did you finally discover the moon of Pluto?
Well, Bob and I were working together in Washington, and we had requested that photographs be taken here in Flagstaff with a 61-inch of Pluto so that Bob could determine positions of Pluto in its orbit.
At the end of the observing season, when I knew we had enough plates, a measuring machine was available to measure positions of stars and planets. I gave the plates to Jim and asked him to measure them for me the following day.
So I came innocently to work one Thursday morning, June 22nd, started looking at the photographs on the measuring machine. I noticed that there were some elongations of the images on the photographs. It did occur to me that it was possible, because these photographs were taken on 3 different nights, that it was possible there was a moon orbiting the planet, and that it showed up on the northern edge and then on the southern edge.
I, at the same time, making only 1 or 2 very simple assumptions, decided to compute an orbit for the satellite with respect to the planet, which I did driving home in rush hour Friday evening, as a matter of fact. Monday morning, Jim had his measures. I had my computed positions from my orbit. We looked the 2 over together and discovered we had better agreement than we were entitled to, so we were now confident that we understood what was going on.
Using a technique that unfortunately makes Pluto look square, astronomers have finally managed to see Pluto's moon, Charon, as a separate body.
You 2 guys discovered a moon. Were either of you excited about it?
I was not as excited as Jim was until we sat down and did the last number, which was to calculate the mass of the planet. And then we discovered that the mass was so small that we had a true anomaly, something new going on. That's when it began to get exciting.
The anomaly was that Pluto and its moon were just too small to have any effect on a giant world like Neptune. But something is. Many scientists believe there has to be a 10th planet beyond Pluto, a new Planet X. The same thought had occurred to Clyde Tombaugh and the director of the Lowell Observatory back in 1930.
So Dr. Slapher asked me to continue the search, which went on for 13 more years, and I found nothing more. And I saw individually in that interval 19 million star images, and I sat 7,000 hours at the Blink comparator and searching this out. And no more planets showed up.
But the evidence for a Planet X is so strong that astronomers are still looking. With the help of modern telescopes, Bob Harrington thinks he's hot on the trail.
I propose to use the classic blink technique just as Clyde Tombaugh used in 1930 to discover Pluto. That is, I take two pictures of the same region of the sky a couple of days apart, then look for the telltale jumping back and forth of the planetary image with respect to the stars. So far, I've had no luck.
Nowadays, that's not the only technique available to us, is it?
That certainly isn't the only way, and the most promising way around right now is with the IRAS. If the thing is there, I'm sure it's in the IRAS data someplace.
And I'm Roberta Piazza at Vandenberg Air Force Base, where the launch of an infrared satellite telescope may give scientists a new view of the heavens.
January 25th, 1983, IRAS, the infrared astronomical satellite, went into orbit above the Earth. Its infrared eye revealed millions of hitherto unknown objects in space, amongst which might lurk Planet X. All this new information was beamed back to Earth and received at the Rutherford Appleton Laboratory in Oxfordshire. IRAS made many far-reaching discoveries during its year-long lifetime, but 60 miles of data tapes are still waiting to be analysed. The information is passed to an international team of astronomers, which includes Chas Beichmann of Caltech, who's particularly interested in Planet X.
Well, IRAS went from the very, very distance where we've had amazing discoveries about distant star-bursting galaxies, and as we come closer and closer to our own solar system, there are a number of important unanswered questions. There's evidence from a variety of other spectral regions and other kinds of data that there is, in fact, another planet that's part of our solar system, but no one has yet seen it. It's very faint, hasn't been seen visually in the years that people have spent looking for such things with large optical telescopes. And there's a good chance that if the planet is of a certain kind, a certain temperature, a certain distance away from the sun, and if it's there, its signature may actually be lurking in the IRAS database.
So how do you propose to look for Planet 10?
Well, there are a number of different signatures of what you call a planet in the solar system. Probably the most important of which is the fact that planets move during the course of the 1 year that IRAS was taking data. So one of the things that members of the IRAS team are doing are to look through the data and try and find an object that looks almost the same in its brightness and in its color and so on, but might have shifted position from one time when IRAS looked at it to a time 6 months later when we came back to look at the same general piece of sky. It's a very hard problem. It's looking for a needle in a haystack when you're in a field with lots and lots of haystacks and maybe no needle. But it's a very exciting possibility that a number of the IRAS team members and now other investigators are pursuing using the IRAS data.
In this series so far, we've looked at all the known planets in the solar system. But does Pluto really mark its outer boundary? Beyond these known worlds, scientists are convinced there lies a Planet X. Will it be discovered by Bob Harrington with his telescope? By Chas Beichmann searching the IRAS data? Or perhaps not by a human being, but by a man-made explorer deep in space? The Pioneer probes are fast approaching the zone where scientists think Planet X might lie. Any slight changes in their paths caused by the planet's pull will be detected by the receiving dishes back on Earth.
And so this great ear, listening into messages from robot craft well beyond the bounds of the known planets, may bring us the first whispers of the outermost world of all.